Hi everyone, my name is Jean-Christophe, and today I'm going to teach you how to use Scikit-learn linear regression to make a simple linear regression in Python. So linear regression is using ordinary least square linear regression from Scikit-learn to predict values. So it is found in the Sklearn linear model module, and the linear regression class fits a linear model to minimize the residual sum of squares between your observation and your prediction. So as a nutshell, a linear regression, it is trying to fit a line on data points so that you minimize the sum, the residual sums of square. So we have an intercept, we fit a slope, we fit a line using the slope, and then we calculate the residuals here, each of them, and we make the sum of it squared, and that's what the linear regression tries to minimize, the average error that you get from RSS. So the first thing you have to do is you need to pip install scikit-learn matplotlib for this tutorial. And what we'll do is an example on the diabetes dataset. So the diabetes dataset, it is a few physiological variables that creates a feature. So you can have the X, say, sex, age, body mass index, blood pressure, and we try to predict the disease of diabetes on this after 1 year. So we will load the data, and by loading the data, what we'll find here is that we have a few features, and these are the ones that I've told you about. And here we want to do a simple linear regression, so we will only do it on the body mass index. So we will only use the body mass index in order to try to predict diabetes. Here generally when we do machine learning, we try to have a test set apart so that you can look at your accuracy score, and that's what we do with train test split. I'm not going into this train test split for this tutorial. I have a video on it, but essentially we are getting training data and testing data from this, so we're splitting and keeping one part for testing later. Now, what we want to do is actually train a linear regression. So linear regression is found from Sklearn. So you go into the Sklearn library and you go from linear model module, and then you import linear regression. And to train the model, we set up a variable to do linreg, and we use linear regression. And then we use that variable to fit the data. So fitting means training. So we train the data on the X train and Y training data. So you can see I'm not using X and Y, I'm just using the training data from X and Y. And I'm trying to predict Y here, and I use the linreg trained model, and I'm using this to predict using X test. So I will take X test and try to predict Y based on our linear regression. I told you a linear regression tries to fit a line, so we are going to look at the intercept, which was a star on my graph, and linreg, and we will get the intercept attribute from our trained model, and we will get the coefficient of the linreg, and we get the coefficient attribute, and we select the first coefficient, and essentially we are going to print the intercept and at point zero the intercept and the BMI. So essentially the disease progression of 1 unit of BMI is 988. So let's try to plot this. So I'm going to use Seaborn regplot. I have a tutorial on Seaborn regplot that you can look at, but essentially I'm going to use Seaborn regplot to set x, and x will be defined as x test. So we're going to use test, and we will use the BMI, and we will set y equal y test. So essentially, we will do a reg plot, and then we can add some information like the title, the X label, and the Y label to put some axis on our chart, and then we do plot show, and we run this. So here I have my linear regression with intercept 150 at point 0, and the slope of this is 988. So here, if you can see, it stops only at 350 because our data, but our axis is 0 from 0 to 0 0.15. But if we were to expand this to 0 to 1, we would see 988 here. So that's what the intercept is. Now, if we want to compute the accuracy score for this simple linear regression, we will import metrics from Scikit-learn. So we use Scikit-learn import metrics, and we will import NumPy as NP. So here I'm not going too deep into what these metrics are. There are tutorials on the topic, but essentially to fit our model, we will try to figure out the mean absolute error, the root mean square error, and the coefficient of determination, the R2 score. So in order to get these metrics, we take metrics, we use mean absolute metrics dot mean absolute error, and then we pass in the y tests and the y pred. So it will compare our test and our prediction of y, and it will look at this absolute error. We will want to look at the range of y. So we look at the minimum value, and we use np max of y to showcase what is the range, so that we can compare the mean absolute error to a range. And then we will look at metrics root mean squared error. Uh, Initially, we were passing mean squared error, and the attribute was squared equal true, but that's not true anymore. So we have the root mean squared. It was deprecated, so now we use the root mean squared error, and we use y test and y pred, and then we calculate the R2 score. We can use again the metrics R2 score. So there are multiple convenient way of calculating this without us having to go through all the maths behind it. And then if we print all of that, we get that the absolute error here is 50 units. So if we compare, so essentially what the mean absolute error is, it will look at how much the prediction deviate from the actual value. So if you compare your prediction and your actual value, how much on average are we far off? In this case, we are far off by 50 units and of BMI. And if we look at the range of the disease progression, so not BMI, but the disease progression, and if we look at that range, we go from 25 to 346. So if we are on average wrong by 50, it's quite significant. It's not like completely out of it, but it's quite significant. If we look at the root mean squared error, then that's the magnitude of error. So what we're saying here is we have 62 unit. So it's somewhat accurate, but it's still a high error. And we have a coefficient of determination of 28. So it says how much of the variance in the target can we explain with BMI, and it's only 28%. So it's quite weak. So in this case, that is a value from 0 to 1, and 28% signifies a weak relationship. So in order to fix this, we can add more features to get a better performance. So we can improve score by doing some data processing that we haven't done in this tutorial. We can do feature engineering to generate new features and try to improve the score. We can do hyperparameter tuning and cross-validation to select better uh, our hyperparameters, and then we can use different models instead of linear regression, or even select better features. So this is it for the simple linear regression with scikit-learn. So feel free to follow me and help me by subscribing to this channel, or ask me any questions that you want in the comments. See you next time.